Can or not? Or cannot? Oh, okay. Yeah, at least I see an icon. So I assume that everyone can hear me clearly. Or okay. I think after MCO, I seldom have an online class at home. Usually in my office, okay, because all my teaching materials I usually put it in the office nowadays. I don't bring it home. So just now I was like, oh, so many things that I need to update. My tablet, my Microsoft team. Okay. So thank you for waiting for me. Because this morning, I think around 11:10, okay, 10 minutes past 11, suddenly office don't have an internet connection. So I was like, it's still early, all right, I can wait for it. But I think I wait until 11:40. Fortunately, my house is very near to the university. Okay. I stay in section 16, PJ. So around 40, I think I better go back home because still don't have an internet connection. And I don't want to postpone or cancel the class because next week onwards, we will have a presentation assessment. Okay. I would like to give you all more time, okay, for your presentation or for Q&A. So I say, it's okay, let me go back home. So I was very rushing. Thank you for waiting for me, okay. Really appreciate it. So let's see, okay, before we start our lecture, let's go through something first, okay. So first thing, of course, is an assignment, okay. Don't forget to submit it. I think tomorrow will be the last day, the deadline, okay. So far, 2 groups have submitted, okay. 1 group save it as a draft, okay, no problem, okay. I suppose we have 11 groups, okay. So you still have 7 groups, 8 groups, okay, haven't submit yet. So you all please make sure you submit it today or tomorrow. Don't wait until last minute, okay? I think today, tonight, or tomorrow, as you can see, our system always down, okay, out of the reason, okay? Even you keep it as a draft also good, because I think by the time close, at least you have a draft there, right? Okay, and some of you told me that after you submit, you cannot change it, right? Let me see. Is there any ways that I can do it so that you can replace your file? Let me see. Because I know that sometimes maybe last minute you still have you realize that something you want to change, right? Okay, no problem. Because I actually prefer, okay, you have a double check. Everything should double check. And, before you submit, let me see the setting. Is it allowed you to resubmit? This one. Feedback submission setting. Maybe this one set to unlimited. Not sure whether this will be, you will make you able to save. But then sometimes I know what's the problem, because sometimes if we do this setting, they will show 10 files, and then in the end we don't know which one is the final one. Let me see one more time, okay? Maximum number is 1. So by right, if you override it, it should be override. It won't be there. Okay, yes. Yeah, I think at 10 is the unlimited, should be fine. Okay, so you all please, if you think that you are not satisfied with your submission, you can override, but I think only up to tomorrow. Okay, so if you have time, you can submit now. Okay, this is the first thing. For the second thing, by right, today we have attendance, right? But then I remove it, okay, because I set a short quiz. Okay, after the class, I want everyone to try it, but it's a very simple one. 10 Q&A on MQA only, multiple choice question, MCA. So therefore, everyone please try, okay? This quiz will not affect your assessment, continual assessment mark, okay? It's just a quiz to test you for your understanding, okay, on this topic, as well as record it as your attendance. Okay, so as you all can see, the quiz, I open it at 2 o'clock, okay, and then I close it at 3 o'clock. So this 1 hour is for you to record your attendance. If let's say later I finish a class earlier, as usual, I always finish my class too early, right? Okay, so if I finish it early, I will set it earlier. Okay, if let's say I finish at 1 o'clock, I will set it at 1 o'clock onwards. Okay, hopefully won't lah. Okay, I think one of the problem of my class is no student ask question, right? So sometimes I feel very, very bad to you all. Like last week, we only have our class 1 hour and a half, right? Then after that, I have to say bye-bye to you all. I feel very bad, you know. I feel like you 3 hour class, we only make it 1 hour and a half. By right, okay, when the faculty make it into seminar style, we are supposed to teach a lecture for 2 hours, okay, 1 hour for tutorial. For that 1 hour, I don't feel too bad because previously when we don't have a seminar style, we normally only conduct our tutorial class for 9 to 10 weeks like this, okay? For another 4 weeks, normally we don't have tutorial. Like for example, the beginning of the semester, normally we don't have tutorial, right? Or, you know, during the midterm test, okay, or during the revision week, normally we don't have a tutorial. So I think like sometime like now, or when we have an online class, or if a class end at 2 o'clock, 2 hours, I still can accept it. But if I end at 1 hour or 1 hour and a half, I feel very sad lah. I feel like, yeah, okay, you all should have more things to learn, okay? But in the end, we end poorly. So if you have question, please ask. All right, this is the first thing. Then another one, okay, so we will start our presentation next week. Okay, today is the 30 December. Okay, tomorrow is the New Year Eve. 1 year passed already, so fast, okay? Yeah, 2026 is coming soon. And also today mark the last chapter for this course, okay, financial mathematics. So we will cover everything, our syllabus already, okay, good news. So next week onwards, we will only have a group assignment. So not sure if you observe this, okay, but already put it here, the presentation schedule, okay? So next week, week 12, group 2, 4, 6, and 8 will present. Initially, I want to make it 5 groups, but then I realized that we still have, because we have 11 groups, like, so means that week 14, we'll only have 1 groups to present, like very poor thing. Because revision, normally we also nothing much, maybe just tell you all the tips, right? But then I already informed you all, for the final exam, we will only cover these purple color chapters, right? I told you all last week, in case you didn't hear it, okay? Let me tell you again. For the final exam, we will only cover 1, 2, 3, 4, 5 chapters. Okay, the purple color one I highlighted. Okay, so I think the revision, maybe I will set some question, especially from theoretical or some you know, calculation one, we can do it together for 1 hour. Okay, then the rest we can do the presentation. Okay, so please get ready, okay, especially for the group. If you cannot make it, let's say group 1 really cannot make it in the week 13, you can change with your other groups, okay? But in the, how to say, but important is you might get their consent, okay? You must get their permission. If they say yes, only you can change. You cannot force them to change with you, okay? I understand sometimes maybe one of the most important person, as you already planned, sometimes some groups, only one person to present, have other activity or other, you know, commitments, then you can change, okay? It's okay. You just need to let me know in advance, because why I need to know it earlier, I need to read your report first, okay, before I attend the presentation, so that I understand what are you going to do and I can prepare some question to ask you, right? Otherwise, on the spot, sometimes I also don't know what are you going to do, okay? So it's very hard for me to judge, okay, or to examine you. So if you don't want to present on that particular weeks or that particular time, you can just inform your other friends, okay, other groups, and change with them, and then let me know, okay? Yeah, so presentation, limit it to 10 minutes. Don't make it too long, okay? Because by right, your group assignment only 3 pages, right? Okay, 3 pages, I think 10 minutes is good enough, even for PhD, you know, for their viva, their thesis presentation, these 3 years work, they are only allowed to present in 20 minutes. So I realized that nowadays, a lot of the presentation, they actually don't like long and lengthy presentation. Okay, that's the key. Okay, you all need to learn how to make it, you know, within a short period and people understand you. Okay, like you see, even in the scholarship interview, when I received a scholarship for my PhD, I took this math scholarship, very I think Japanese famous scholarship. If you're interested for your master and PhD, you can also search for it. MEXD Mombuko Gugashoa. Okay, yeah, it's a famous scholarship they give to Malaysian every year. At least 3% will be selected. Okay, if you are interested, next time you can apply for it. Okay, during this for this scholarship, they ask us to take the test, right? You need to go to the embassy to take the test, and meanwhile, they also will ask you to have a presentation. Okay, but this presentation is included in the how to say interview. Okay, so therefore, as I said in the early of a semester, actually presentation is very important. So if can, I actually wish that everyone can try to present to gain some experience. It's not that, you know, I sometimes I don't want my student, okay, to feel worried. Okay, this time I must on my camera. Otherwise, you all will think that I'm scolding you. No, I'm not scolding you. Okay, I just want to tell you with my sincere expression. Okay, yeah. Otherwise, students sometimes think that we give them pressure or we force them to do something they don't like it, right? Okay, I must tell you honestly, it's not okay. My intention is only I want my student to learn from experience. Okay, for presentation, okay, 10 minutes. As you all can see, I think presentation only have how many marks? Only 10 marks, right? Okay. Anyhow, my style is I won't give my student 1 marks only. That's not my practice. Okay. Even the worst, I think the student, they really don't put in efforts. I will still give around 5 marks, right? If you took my previous course, you should know that I'm quite generous in giving I think, okay, maybe not really like that, but in my own opinions, okay? So take it as an experience to present. But if you already, you know, manage, you already plan for it and you're really not ready to present, it's okay. Even until now, every time when I need to present, when I need to go to the conference, when I need to present in front of the big audience, I feel very stressed, okay? I have to persuade myself, I have to practice, I have to write down the script, okay? And then stand in front of the mirror, practice again and again. Public speaking is not my cup of tea, I have to tell you honestly, okay? Even though I'm a lecturer, I always need to teach in front of so many people, right? But then still, every time when I was invited for any big talk, my life is difficult. I feel that's okay. Yeah. So therefore, I can understand everyone when you say that you don't want to present and you know that some of your friends, they're really good in presentation. It's okay, okay? I won't judge you, as I said, because I didn't mention like everyone must, you know, present. Okay, I just mentioned all group members must contribute. But if you want, I encourage you to present, okay? Because later you will have to present a lot of time, okay? Yeah. Not sure whether you will further study or not, but I think even for your interview, okay, yeah, for PhD, we also need to go through interview because your supervisor need to see you. They want you to present your idea, your proposal. Not only they will think, they give 10 minutes is as I said, sometimes may fall asleep. Okay, so therefore, try to make it into a precise one. Okay, you should decide what should you present, what is the important thing, and when you present in the short or simple way, okay, how to immediately let your audience understand you and attract their mind. I think this is an important thing, okay? So 10 minutes, if you say it's too short, it won't be short, okay, if you know what you want to present. But okay, if you too much thing to present, yeah, it may be too short lah. Therefore, you need to decide, okay, life sometimes is about sacrifice, right? Okay, even like us, okay, when do research, my student, sometimes everything also they want to put into the thesis. Okay, I told them, I say don't do like this. Okay, many people are not patient now. They even, I think even live entertainment nowadays, short video is the famous one, right? If I'm not sure whether you all watch a short video or not. Like me, I actually watch a short video. I especially like to watch it when I have a lunch, okay, in the office, or when I have but dinner very seldom lah, because the dinner I need to have a lunch, a dinner with my daughter, 5 years old. So if I do like this, she will follow me. So I have to force myself to put down the handphone. But in the office, when I have my own lunch, I like to watch the short video and eat. I don't like, but one of the reasons I don't like long video is because it attract me for too long time, wasted my time, right? So I want to make sure when my lunch finish, I can put down my handphone. Okay, so I think if this is a trend, the market, I think everyone likes short thing. Okay, so you all please, train yourself how to make it short, like your report, actually up to 3 pages only. Okay, a lot of you contacted me, say that, can you please go through my reports because we already completed it. Can you give us some suggestion or opinion? I rejected them. I told them that my practice is I normally don't give students any comment before submission. Okay, why? Because in my opinion, if I give comment, you definitely can change already, right? You can enhance it, you can amend it. Then what's the point after that? You see, after you submit, then I definitely will give you 100 marks already, because you already changed according to my comments, right? So if I still don't want to give you 100 marks, means that I'm not satisfied with my own comments. My opinion is like this, okay? And so therefore, another reason I will think that if I give this group 1, for example, some comments, then they enhance it, they get 100 marks. Then how about the other 10 groups? I think that it's very unfair to them. So I normally, my practice, no matter it's a master, undergrads, or PhD, I don't give comment before the examination. Okay, so but after that, I will give comment. That one is for your own improvement, okay, for your own understanding that what's wrong, okay, why I only give you 8 marks, for example, okay, yeah. I think more important than the CGPA is we learn from this process, right? Okay, because this one is just a small course. It's just an elective, okay? I want to make it clear. It is just an elective. Elective means that it's up to you whether you want to choose this course or not. It's not compulsory. So when we say not compulsory, it means that it's not so important as your core courses. Core courses means that it's so important that we must force you to take this course, okay? But this is an optional course. I don't mean that it's not important, but I just mean that you only need to take it when you are interested in it, okay? Maybe some of you very interested in finance. You are not so interested in this mathematics, okay? It's fine because we always learn from different perspectives, okay? So for me, this course should be should be a way for you to enhance your other knowledge, other than the core courses, okay? So, yeah, so take it as a relaxed way, happy way, okay? When you discuss with your friends, okay, how to present or how to write the report, I wish you learn something else from the mathematics or something else from the finance thing, okay? Yeah, so that, next time, who knows, right? During the interview, they say, okay, you are economics student, okay, as please unmute yourself.
Hello, Doctor.
Hi.
I would like to reconfirm about the report.
Mm.
So, do we really need to put the conclusion for the report, Doctor?
The best is to conclude it lah, so that I want to know that what is your final conclusion or summarize for your whole report. You can summarize it, yeah. Normally conclusion, of course, the best conclusion is not only summary, all right? even for the PhD thesis or research paper, we often need to write the conclusion. Okay, conclusion. If you see the journal paper, a lot of people they like to summarize what they do. Okay, what they did. For me, it's not so good because if people want to see the summary, okay, why not they just go to your abstract, right? Okay, but this is one of the way. Conclusion can be just a summary, but the best is what is the final message that you want to tell us after you do all this research, right? Okay, for example, I saw a lot of you choose an EPF, this kind of thing, right? For example, you say, oh, should we save in the EPF or should we save in the unit trust? I just simply say, okay. So finally, conclusion is what? Then you tell us that, oh, okay, based on the interest, okay, and the long-term period, we think that better you save in EPF, okay, because it's safer, okay, the risk is lesser, something like this, at least you have to explain. But normally conclusion, you don't need to write so long, it should be conclude your study. So I think one is too less lah, okay. I think 3 sentences should be good enough, around 3 to 5 sentences. So, yeah.
Okay, sure, Doctor. Thank you so much, Doctor.
Any other question? Good, because you still have 1 day, right? If you have anything you are not confirmed, you also ask. Therefore, we always end the class too early, and then after that, a lot of questions that you all don't know how to solve it. Any other? I can't see your face also. Don't worry, you see you are not on your camera also. So if you have a question, you can just ask, right? Okay. If your last chance, no question, then we will start the class. Next week, you don't tell me that you don't know how to meet the requirement, okay? But I think it should be clear because every week we are talking about this, right? Okay. The only bad thing is it is a 40 marks, so I think it's quite heavy. Okay. Now let us start. Don't look at my face already. We just start our lecture. Today is the last final chapter already. Okay. So as we always mention, I go through the whole textbook, okay, before the semester start, right? Actually, this is my first time teaching financial mathematics. I asked my head of department, I say, am I qualified? Okay, because I'm only good in mathematics. I'm not good in finance at all. Okay, my own finance is in the mess, right? Okay, but then they told me it's okay because of financial mathematics, I use a lot of mathematics, so you definitely can handle it easier, right? Then when I go through the whole textbook, okay, sometimes I have this question. Okay, why they purposely want us to study, this forward and future lah, okay, the option lah, okay, and all this. Then I ask the ChatGPT lor, okay, I ask AI, I say, for this financial mathematics course, okay, why this is important, okay, yeah, and ChatGPT, the idea say that, okay, for the finance, okay, the most important idea is they always want to maximize the return and they always want to minimize the risk, okay, yeah, because that's the only thing, as an investor, okay, they can, earn their profits, right? So they always want to, this is their important thing, and minimize the risk. Okay, so therefore they say, for all these things that we have learned, the central idea is always this. Okay, so same goes to today's chapter, optimizing portfolio. Okay, I think everyone understand this thing, right? Because a portfolio, it just means that you have a multiple investment. This one, even though I'm not a finance people, I also understand it, right? Okay, so we have a very famous slogan, right? Don't put all eggs in one basket, right? If you accidentally drop it, then all your eggs will be gone. Okay, so therefore, if you really want to optimizing your portfolio, okay, one of the best way to do it is diversification. Okay, diversify it. Okay, so therefore, this is a central main idea for this chapter. Okay, yeah, and before we start, always remember, okay, as what econs teach us. So sometimes economists, for me, I think they are very smart. Okay, they always say that we can't maximize something. Actually, the best is we optimize it. Okay, optimize it means that, of course, it's a maximum it, but this maximum it, okay, is up to your preference. Okay, later we will go through all this. So for this chapter, the textbook also mentioned, okay, for many investors, they doesn't mean that, they don't mean that they want to reach 100% return, but they just want to reach the return they are satisfied with. For example, okay, now if you have a 100 ringgit, okay, you want to invest this 100 ringgit, okay, for you, your own feeling is, okay, as long as I can get, like, for example, 120, I'm happy with it. Okay, you no need to force yourself to get 1,000 or 100 to become 1,000, for example, like just an example. Okay, so everyone has their own preference. Okay, maybe for investor A, okay, as long as I can earn 20 ringgit, I'm good enough. But for investor B, maybe they want to earn 900 ringgit, only they will be happy. Okay, or maybe for investor C, okay, as long as maybe 500, something like this. So you can see everyone has their own different targets. Therefore, we want to learn about how to optimize your portfolio. Okay, your own portfolio. Every different investor has a different portfolio. All right. So you can see the investor, they may wish to adjust the allocation of the financial resources, including a mixture. Okay, this is an important mixture. You can have some cash. Okay, you can invest some money in the bond. You can also invest some money in the stock. Okay, or you want to protect yourself. Okay, you can buy some option. Okay, or other financial instrument. Okay, yeah. So as a method to achieve some time of optimality. All right. So you can see about this chapter is all about adjust the allocation. Okay, among so many financial resources, you just want to, diversify it. There are various equally valid notions for the optimality. Okay, for this, okay, the textbook say that when we talk about optimality, okay, there are few items, okay, few notions to explain it. First, you must have a maximum rate of return, okay, maximize your return, or you want to minimize the deviation from a chosen rate of return, okay, or the easier way is minimum the risk. Okay, so when we talk about maximum return, this means that you want to have the as much as possible income, right? The return. When we say about minimize the risk, means that we don't want to have a fluctuation too much. Okay, for example, you don't want suddenly, have a shock on your investment and then you bear the risk, right? Okay, well, what means of a minimum deviation, okay, from a chosen rate of return, minimum deviation from target, means that meet my commitment with high confidence. As I said just now, because different people, they have a different target. Okay, for example, you invest 100, you aims to have a 120. So, okay, this is your target. Right? So you want to meet your commitment with high confidence. So means that you don't want to deviate too much. If let's say you earn 115, this one you still can accept. But if you only earn 95, you even have a negative 5, lose a 5 ringgit. That one is too much for you lah. Okay, so therefore, some of the investors, they want stable, in return. So they don't want to deviate too much from their targets. They want to meet their commitment with a high confidence. Okay, so they are more to the risk averse investor. Okay, so anyway, the important about optimality is always maximize the rate of return. Okay, minimize the risk. Okay, yeah, minimize the risk and also minimize the deviation. Means that don't have a too much difference from your target. See, different investors care about different trade-offs between return and risk. For the risk-seeking investor, okay, they are fine, okay, yeah, even if the risk is higher, okay, they just want to focus on the maximizing the expected return. But for the risk-averse investor, okay, they just want to minimizing the risk, okay, they are not so focused on maximizing the expected return, okay, they don't want to take too much risk. Okay, so the investor must choose the type of optimality they wish for their portfolio to have. Okay, so if you are the risk-seeking investor, okay, then you always can invest in the higher risk but higher return portfolio. But for the risk-averse investor, okay, you might want to focus on the portfolio that has a lower risk, okay? But meanwhile, we also know if a lower risk usually means that lower return as well, okay? Yeah, it's fine because every investor is a different. So every investor will have their own portfolio. Okay, that is why modern portfolio theory mentions that there is no single best portfolio. There is no single best portfolio in the market, okay, because everyone define it differently. Okay, you have to understand for the risk-seeking investor, they define portfolio as a different way than the risk averse. Okay, so therefore, okay, for this optimizing of the portfolio, we always offer a set of optimal portfolio, okay, depending on the investor preference. Okay, we won't say that, oh, this is the best, okay, but based on the different investor, normally we have a different types of a portfolio. So for this chapter, okay, because we are talking about diversification, right? So one of the key ideas to measure the diversification is a covariance. Okay, yeah. So you can see what means of a covariance. Covariance is a measure of the degree to which two random variables tend to change in the same or opposite direction relative to one another. If X and Y are the random variables, then the covariance is defined like this. Okay, so in the easy way, for example, you can see, let's say X is a bond, okay, then Y is a stock. Okay, so let's say you have these two investment, okay, yeah. So if these two variables tend to change in the same position, okay, it means that you actually not doing the diversification. Okay, so when let's say when there is a shock come, okay, when a shock come, then this bond, the X and also the Y, they move in the same direction. Okay, both of them, let's say, increase. Then you are not diversified, right? Okay, or both of them when there's a shock, they both the price decrease together. They are moving in the same, they change, okay, in the same direction. Then you are actually not doing any diversification. Okay, but if let's say when there's a shock, okay, X increase, Y decrease, then this one is actually diversified. Okay, so something happened, okay, you won't lose all your investment, your portfolio, they are acting differently, right? Okay, they can actually minus out the risk, the loss that you experience, right? So therefore, covariance is an important key concept, okay, in this portfolio diversification. So you can see when the covariance are greater than 0, means that X and Y, they tends to move in the same direction. But if they are smaller than 0, okay, means that they are moving in the opposite direction. When they are equal to 0, means that there is no linear relationship, means that there is no linear dependence among each other. So here, okay, yeah, here want to emphasize to you that portfolio risk, okay, not depending on the individual risk only. Okay, some people, they think that, oh, if I want to see whether stock or bond, they are risky or not, I just want to see their their past historical move, right? Okay, not only this, but you must also remember that, okay, portfolio risk also depends on how other assets move together. Meaning that you cannot only look at the past historical price for the bond only, but you should look at the stock. You can look at the other financial instrument as well. Okay, yeah, how they move together. Okay, the portfolio risk depends on individual or also on others. Okay, same like our econs, right? If you understand economics already, we know that price, okay, let's say price of X not only depends on the quantity of the X only, sometimes it also depends on the price of a Y, the quantity of the Y, right? This is what we learn in the microeconomics, right? So same goes to this, okay, the portfolio risk not depending on the itself only, okay, not only depend maybe the quantity only, but also depend on others, okay? Only with a low or negative covariance, we can diversify, okay? We can reduce the overall risk, okay? So if you want to have a diversification, you need to make sure that all your portfolio, okay, the asset, they are not moving together. Okay, So this is some theorem about the covariance. How to compute the covariance? Okay, now we already understand covariance can be used to measure the diversification. But now how to compute it? Okay, this is a formula. Okay, the expected value, okay, between when you multiply them together, okay, minus the individual, okay, dependence. Okay, so why? Okay, they show you, okay, this is because they how they derive it. Then therefore we have this equation. Okay, and how to apply it? For example, this table, okay, they show you the height and also the arm span, okay, for the 20 children. So you can see 1 to 20. All right. Yeah, I forgot to bring my calculator back. Okay, but anyway, okay, I can show you how to calculate. Find the covariance of the height, and this one is the height, right? Okay, and this is the span. So therefore, they give you two information already. They ask you to find the covariance. So what's the way? Okay, just now we already know the formula for the covariance is, okay, this is EXY, okay, minus EX multiply with EY, right? This is a formula. So here, first we need to calculate EXY. How to get this value? Okay, very simple. Okay, this multiplied with this, okay, for all, okay, this multiply this multiply this, and then sum them up. So means that 142 multiplied with 138 plus, okay, 148 multiplied with 144 plus, okay, then 152 multiplied with 148 plus until, okay, the last one, okay, 142 multiplied with 138. Then you sum them up. Okay, by right, you should be able to get this value. Okay, then how also because this is an expected value, right? Okay, I think you need to divide it by 20 lah. Okay, because it's a mean. Okay, this one as well. Okay, the EX, okay, it is equal to 147.15. So how to get it? Okay, for the X is the height, right? Okay, then Y is the arm. So this one, okay, you plus everything. Okay, this plus this plus this plus everything, then divided by 20. Okay, because you have 20 kids, right? So I suppose you should get 147.15. Okay, you all know what that means, right? So means that you hear 142 plus 148 plus the 142. The last one is 142. Okay, then you divide it by 20. I suppose you should get 147.15. Okay, and same go to Y. Y means that this one, 138. Okay, this one is for X. Then Y is equal to 138 plus 144 plus until the last one, 138. Okay, divided by 20. So you should be able to get this expected value, 142.7. Because expected value means a mean, right? Okay, so these two, you just multiply 2 and then you divide it by 20. You should get this value. Okay, yeah. So in the end, the covariance is equal to 15.445. So this is a positive value. Positive value means that they are moving together. Okay, they move together. They move together in the, this is not economics thing, right? Let's say in the health issue, it also means what? In general, okay, when you are taller, okay, your arm span also will become bigger. So it makes sense lah, because therefore their relationship is positive. Okay, but if you come to finance, okay, this is not diversified. Okay, because the two of them are moving together. All right. This is just an example to show you how to calculate the covariance, okay? I think the textbook should give us a finance issue, right? Why give us this height and also arm span, right? Okay, yeah. So there are some properties for this covariance, okay? If let's say X and Y, they are independent. Independent means that they don't depend on each other, okay? So their covariance should be equal to 0. Okay, yeah. So just now by using the formula, okay, so we know that this covariance should be equal to 0. Okay, why? Okay, because for example, you can see if let's say EXY, okay, you also if they are independent, okay, then you actually can extend it to this. EX multiply EY. So when EX multiply EY minus EX multiply EY, by right, it should equal to 0. So they prove to you that if they are independent, okay, the covariance will be equal to 0. Okay, but you must remember, when we say covariance equal to 0, does not imply that X and Y, they are in, how to say, they are independent. Yeah, okay, yeah, because, okay, this sentence, okay, let me say, X and Y independent, they're independent, then it means that, okay, covariance is equal to 0. But covariance equal to 0 cannot means that X and Y are independent. Okay, means that terbalik you cannot assume it in another way. Okay, yeah, only when X and Y are independent, we know that covariance is equal to 0. But covariance equal to 0 does not necessarily mean that you cannot assume in the opposite way. Okay, so therefore in economics, causality is important. Causality means that the direction of the relationship, okay? Is it X cause Y or Y cause X, okay? Like in this case, this cause this, but this does not cause this, okay? Zero covariance, okay? Sometimes when you get a zero covariance, just imply there is no linear relationship. You cannot assume that X and Y are independent, okay? Yeah, they might have other reason. Okay, but if X and Y are independent, then they definitely lead it to the covariance equal to 0. Okay, yeah, I hope I don't confuse you. Okay, all right. So there are some other properties for the covariance. Okay, if let's say you have a 3 variable X and Y and Z, they are random variables, and all these will become true. For example, if you are comparing the covariance because between X and X, then you better use the variance, okay? No need to use the covariance. So if you're comparing X and Y, the answer is the same as when you're comparing the covariance of Y and X, okay? It doesn't matter because it's a linear relationship, right? So let's say, for example, this is a X, this is a Y. If their relationship is like this, so even though you put this as a Y, this is a X, it's still the same relationship, okay? If you are comparing X plus Y with Z, then you can actually separate them, this with this with this. So you can have two parts. Okay, so covariance is linear. Okay, so you can distribute it across the sum. So you can see the covariance between the sum of X and between the sum of Y. Okay, you can do it in this way. You can sum them up. Okay, the main reason is because the covariance is linear. So you can distribute it across the sum. The total covariance of sum is the sum of all pairwise covariance between elements of the two sets. Okay, these are some properties. Well, the last property is, okay, they say that the total variance of sum measure the overall uncertainty or risk of the combined total, okay? Taking into account both the individual variance and how the components co-move, okay? So this is so-called total variance of sum. Okay, means what? Like just now, remember what I told you here? Much really. This one, okay? Portfolio risk depends not only on the individual asset risk, but also on how assets move together. So same goes to this, okay? When we say that total variance of a sum, they not only measure, okay, the individual variance, they also taking into account how the components with others move together. So you can see this is an individual, okay? Okay, the sum of the individual variance, while this one is a sum of all covariance, all co-movement, okay, with other asset, all covariance. So this one is this one. Okay, if you have a positive covariance, means that all the variable they move together. So therefore, they increase the total variance. But if you have negative covariance, it means that the variable move oppositely, okay? So they reduce the total variance. So this is the basis of the diversification, no? Okay, so just remember diversification means that their covariance should be negative or zero, all right? Okay, so sometimes people don't like to use covariance. They prefer to use correlation. Okay, yeah, but sometimes they use a covariance. There is a reason. Okay, why? Okay, you can see more informative than covariance will be information that large changes in random variable X are accompanied by large changes in Y. Okay, so if X and Y are random variable, then the correlation is denoted by this. Okay, so this is a formula for the correlation. All right, we use a covariance divided by the square root of the variance of a X multiplied by variance of a Y. Okay, why sometimes people like correlation? Because correlation, there has a dimensionless number. Okay, means that they don't depend on the unit. Okay, there's no unit counted. Okay, they already erase it. But covariance, they are very depends on the unit itself. Okay, like our econs also the same. Economics, okay, sometimes we don't want to affected by the variance, right? Okay, sorry, by the unit. Okay, so therefore we like to use elasticity. Okay, when one unit change, another unit change. No matter what kind of unit you use, okay, they will just use elasticity. Okay, they just depends on the one movement in how will it affect the rest. Same goes to this correlation. They don't have a unit things. Okay, so people like it. They think that they standardize it. Okay, the value normally is between -1 and 1. When close to 1 means that it has a positive, strong positive, okay, correlation, okay, but if a negative one, strong negative correlation, yeah, so some people, they like correlation, okay, and this is a formula, all right. They also can measure the strength, as I told you, because a -1 to 1, right, okay, when you near to -1 or 1, then it's called strong, okay, but if in between, then normally it's a weak relationship. Okay, yeah, and also you can see the direction. If both are positive, means that they are both moving to the same direction. But if both are negative, okay, means that if the correlation is negative, means that they are moving differently. All right, so you can see if X and Y are independent random variables, then again the correlation is equal to 0. Okay, we say that X and Y are uncorrelated. Okay, so the correlation has this meaning. Positive one means a perfect positive linear relationship. Negative one, perfect negative linear relationship. 0, no linear relationship. Okay, yeah, but non-linear may exist. Therefore, nowadays in the research world, sometimes they don't count on the linear relationship. They use a more advanced non-linear thing. Between 0 and 1, we say that there has a positive relationship. The higher, the stronger. The near to the 1, then it's a stronger. Okay, from a weak to strong. Okay, same goes to negative linear relationship. Okay, so why we want to use a correlation instead of a covariance? Okay, again, because a covariance is a scale dependence, it's a magnitude, depends on the unit of X and Y. But correlation is a unit free. It doesn't matter one. Okay, yeah. So therefore, we can compare across a different data set. Some data maybe they are using the USD, but some they're using ringgit, for example, okay, because we just want to see whether they moving together, okay, the magnitude, okay, or the direction. So it doesn't matter, it will cross out. Okay, but for covariance, you need to, convert it to the same unit. So therefore, some people, they think that it's not so convenient. All right. So for the correlation, this one was a covariance. Okay, now it's a correlation. They also have some properties. Sorry, I drink some water. Okay, so if one variable is a linear function of one another, the correlation is either positive one or negative one. Okay, the correlation, remember, is a linear function depending on the slide of the sign of the slope. Okay, so for example, if X and Y, there are two random variables, their relationship, let's say it's like this. Okay, I think you all are very familiar with this now because you are third year student already. You already took this econometrics, right? Okay, so this coefficient, okay, normally they can use to measure this correlation. All right, okay. So if it's greater than 0, then normally, you know, this correlation is equal to 1. But if less than 0, then it will be -1. Okay, so correlation measure linear association. Okay, so the relationship is perfectly linear here because it's a positive. Okay, yeah. Then there are some lemma about this inequality. They say that if let's say X and Y are random variables, okay, so if for the expected value for X multiplied Y and square, okay, it's always smaller, okay, or equal to the expected value when you multiply them separately, okay. Why? All right, because it essentially say that the magnitude of the expected product of two variables cannot exceed the product of their individual spread. All right, yeah, so this one just want to tell you that, okay, if you, the expected value when you multiply them together, definitely will be smaller than when you multiply them individually. Okay, yeah. So the equality occurs only if one variable is a linear function of the other. This one is just a lemma, okay? Just some properties they tell you about this. Right. Okay, so the range of the correlation is always between -1 and 1. Okay, same like probability. Probability we know so it's between 0 and 1 only. The correlation also got such rules. Okay, the range is between -1 and 1 only. All right, so you cannot just short sendiri and say, oh, I write the correlation equal to 3. Obviously it's wrong. All right, so please remember this. Okay, yeah. So you can see, okay, when you have these rules, right, and then you can put it into this correlation, then you will get the correlation bound. Okay, you can prove that why this correlation is actually between -1 and 1 only. Okay, yeah, based on this equation, this one, okay, then you can put inside, and then in this inequality, then you will prove it. All right, it's between -1 and 1 only. Okay, so you can see we extend from the previous example for the height and also the arm span of data. Okay, so let's say they ask you to calculate the correlation between this and this. And how to do it? This one just now we already have a value, right? 15.445. This one was from here. You no need to calculate again. 15.445. It took from here. Okay, so let's say you already have this, and the only thing now you need to calculate is the variance, right? Okay, because you need this, you need to apply to this formula, covariance divided by the variance. Okay, so you will have this value, then you divide it, then so the correlation is around this. So you can see the correlation is also very high, 0.87. Okay, you know how to calculate the variance, right? I think we tested it in the midterm test. Okay, for each of them, you divided by the mean. Okay, then you will find the variance. Okay, this is, you can check back how we calculate in the beginning. So you will have a 0.87 for your correlation. All right, so you can see still they have a positive relationship and quite near to 1. So it's quite a strong positive relationship. Okay, so in other words, okay, no matter you use a covariance or you use this correlation, both tell you the same message. These two, X and Y, they are moving together in the same direction. Okay, yeah. Okay, but you see this one, the bad thing about covariance is the value is 15.445. Is it strong? We don't know, right? Because 15.445, so what is the upper range? If let's say we are comparing 15 versus a 20, then we say consider high lah. But if 15 versus 200, not very high anymore, right? Okay, so therefore, this kind of thing, it can't really answer whether it's a strong or whether it's a weak. Okay, we just know that it's a positive one. So it means that both of them are moving together. We only can answer this. But for the correlation, because it has a range, -1 until 1, so sometimes easily for us to see, oh, there has a quite strong relationship. Okay, because 0.87 is quite near to 1 already. So this is a beauty that why some people, they rather use the correlation than the covariance. Okay, but actually in the real life, okay, yeah, covariance, okay, after that is a correlation. But in the research world, nowadays people also don't like correlation. They think that correlation is not so accurate because it's a linear assumption. Okay, they think it's very strict, okay, to restrict the relationship. Many of the relationship are actually non-linear. So nowadays, research world, they already move forwards and forwards, okay, to a more and more advanced method to measure the relationship. Okay, but this is a fundamental things lah, okay, to explain to you why, okay, from the covariance, people don't want to use it, but they rather to use a correlation. But after that, why correlation is abundant, you know, they rather to use the other non-linear approach. Okay, but all this is a fundamental thing. Important is we want to understand that how this thing can help us to diversify our portfolio. That's it. Okay, so don't think it in a very difficult way. Okay, the central idea is a very simple. Just want to use the covariance or the correlation to check whether your portfolio, okay, has been diversified or not. All right. Okay, let us break for some time. Okay, now it's 1 o'clock, right? So we have a 10 minutes break. Okay, we will continue at 1:15. So if you want to have a rest, please do so. Okay, hi everyone. Are you still there?
Yes, doctor.
Okay, good. Okay, finally I understand, okay, why online class at home, okay, students sometimes, last time when I chit-chatting with a student, they say, doctor, when we are when we are home, we are very busy one. They say, I'm not sure whether you all still like this or not, but long time ago, they're very funny one, especially during an MCO. They say sometimes my mom will ask me to have a lunch lah. Sometimes I need to drive them to somewhere to buy them something lah. And then sometimes I need to do my housework lah, this and that lah. Then I say, but during the online class, can you hide yourself in the room? They say cannot one. We have too many things to do. Today, I have a class at home. Finally I understand 10 minutes. Just normally I won't give a 10 minutes because 5 minutes waiting for the class at the office. At most, what I can do is go to the washroom only, right? After that, I have to wait there and I can't do other things. So I normally just want to faster finish the class lah. But just now 10 minutes, oh, I went to the washroom, I drink water, I even can take some snack. I said, oh, no wonder lah, huh? When we were having class at home, normally we cannot sit there forever. The longer the break, the better, right? Okay. Yeah, so so I hope now you are focusing, you are listening, or you are just open there and then dreaming. Did you all go back hometown or you all stay in the hostel? Or you all stay in KL in your rented house? Because you are second or third year, right? I don't think you still can stay in the hostel. Yeah.
You all go back.
You all go back or stay in KL.
I'll go back to our hometown.
Okay, good. Okay. I think you can enjoy some time at home. Don't come back to KL on Sunday, okay? Actually, last week I also went back to my hometown. I'm from Kedah. Yesterday, on Sunday, it was a terrible jam. I spent 10 hours to come back to KL. So poor thing. I told my mom, I said next time I don't want to go back during the long weekend already. I want to go back in, when everyone is working, then I take my leave and to go back. Right? So you also don't come back on Sunday. You may choose, you can plan for it. You may come back on Saturday, okay, or Friday. Empty the traffic. But even nowadays, empty the traffic, a lot of people, they like to come to KL also, I think. So you better come back on Saturday. I think Saturday, seldom they have a traffic there. Everyone to come back, last minute, right? Okay, you all please plan for it. Okay, but who knows? I think nowadays the student love to use the train, the ETS, right? Okay, that is also a good choice. I also love it, but always no tickets one. Very hard to buy. Okay, so now let us continue. Okay, I know you are very enjoy, okay, at home. You enjoy your life, but then let's finish it. Okay, so now we finally come to the financial example. Just now the height and the arm span is like no relationship to the finance, right? Okay, so let's say when we come to finance thing, okay, how to apply this variant, how to apply this covariant thing. Okay, so let's see the portfolio variance and covariance. Suppose you have a portfolio, you have a investments. Okay, remember when we talk about portfolio, it means that multiple investment. It definitely has a S1, okay? It won't be one investment, all right? So now imagine that this is a portfolio, they have a multiple investment, W1, W2 until WN, okay? And with a corresponding random variable rates of return, okay? For each of them, this is their return, okay? Then suppose this investor, she or he holds a portfolio of an investment. Okay, so WI is the amount invested in the I asset. Okay, yeah. So this is the amount he invests in this I asset. Any random one lah. Okay, let's say they have an N investment. Okay, and we assume that N is equal to 10. I maybe is I is equal to 8. Let's say this is a number 8 investment. Okay. So this is the amount that this investor already, invest the money in this asset. And X, okay, is a final well per unit invested in this I asset. Okay, it's a final one. Okay, final well. So then the rate of return, which measure the percentage gain relative to the initial investment, will be this formula. Okay, this is acceptable because the rate of return always the new minus the old and then divided by O. All the formula for the rate of return is always like this, right? Okay, current one, new means a now one, the latest one, minus the previous one, then divided by previous. Same goes to here. When the rate of returns, okay, when you want to measure, it just means that the final well minus the initial investment divided by the initial investment. Then you will know, okay, how much, the percentage, okay, change, okay, compared to the initial investment. Okay, so if you simplify it, final well divided by initial investment is a X. Okay, because here you see, final well per means that divide, right? Okay, unit invested means that the initial lah. Okay, yeah. So this is a final divided by initial. So final divided by initial is X. Then initial divided by initial is 1, same thing, right? So minus 1. So you also can simplify it in this way. Okay, so now there are few things, okay, we can observe from this information. First is a total portfolio well. Okay, total portfolio after one period. Just now was a I asset, okay, but let's say this is a total, then we use a big letter to represent it. Normally the big letter means that the total population, total well, right? So the summation, okay, because you want to calculate total, so you need to sum them all. So let's say you have a 10 investment, okay, equal to 10, then you need to sum them out lah. All the investment, okay, for this 10 of them, okay. So if you simplify it, okay, this one, okay, remember R is also equal to X minus 1, okay. So you can also get this one. R is also equal to X minus 1, okay, yeah, see. So if you XI is equal to RI plus 1, okay, so therefore you see X is equal to RI plus 1. All right, so this is a total well formula. Okay, and from here, you can see that these separate into the initial investment, this one, because if you multiply it in, you will have WI, okay, plus with WIRI. Okay, you can see that. So this is an initial investment. This one is a gain or lose, okay? Yeah, for all the portfolio that among them. Okay, so you can sum them up, okay? Then you will have a total well after one period, but in this case, only one period, okay? Yeah, so you can know. So how about the expected portfolio? Okay, well, okay, so because this one we're assuming is a linear one, right? Okay, so for the expected, you just put the E in this capital letter W. Okay, so this is what we get it just now. Okay, we want to calculate the expected value. Okay, so you will have this. All right. Okay, only the return, the expected. Okay, because this one is a constant, right? Okay, the rate by right, you already know it is a constant, the initial investment. So therefore, there's no expected value, to calculate. But this one, okay, is not a constant, so therefore it will be here. So if you separate them, the expected well will be the initial investment, the constant, okay, plus with the weighted sum of the expected return. Okay, so this is a way. So how about the portfolio variance? Okay, the portfolio variance, imagine the total risk of the portfolio. All right, so we have to use the properties of a variance and covariance. Okay, so again, remember just now, okay, these are important properties. If a covariance between X and X is actually equal to the variance, all right, So therefore, and also we mentioned that, okay, when we want to see the whole market, the total risk, okay, we have to calculate their individual and also the core movement between the asset. So this one actually is a covariance for itself, okay, but covariance, the X with X is actually equal to the variance, right? So therefore, we can extend it to the variance. While this one is a covariance orange color one is a contribution of how asset return move together, okay, move together with other asset. Okay, again, if this is a positive covariance, means that the portfolio risk is actually increased. Why? Because you are not diversified it. Okay, they are moving together. But if you have a negative, then you will reduce the portfolio risk, okay, because you have the diversification benefits. Okay, it's the same thing. Okay, just now when we apply it to the portfolio, you can see this is a way how you calculate. So this is the core idea of the modern portfolio theory. Okay, risk depends not only on the individual asset, but also on how they co-move with others. Okay, this is a modern one, but actually our econs, as I said, observe the risk from the bond, from the option, from others, because it will affect how the investor, redistribute their asset. Okay, so this is the thing. The modern portfolio theory tells us that if you want to see the risk of an asset, you cannot see on the individual asset only. You also have to observe how they co-move with other assets. Okay, the portfolio variance combine individual variance, individual and the pairwise covariance. The covariance is a mathematical expression of diversification. Okay, always remember when we talk about covariance or the correlation, it usually is a mathematical expression of diversification. Okay, if you invest in assets that are not perfectly correlated, will reduce the overall risk. So it's better, okay, you do this diversification. Okay, so far so good. Okay, so now we come to this utility function. Okay, I think utility function is easier for the econ student to understand because we always talk about utility function, right? Especially in microeconomics. Okay, so again, to let you remember what is a utility function, I told you all many times already. For me, okay, for me, I must write for me, okay? For me, the easier way to understand utility, I always equal it to happiness. Okay, or satisfaction lah, but also the same thing lah. The happier I am normally means I'm very satisfied with it lah, right? So utility function is all about happiness or satisfaction. So you can see utility function, they only assign numerical value, okay, we call utility, to each possible outcome of an experiment or investment. This value represent the investor level of satisfaction or preference for that outcome. Okay, it means that this utility function help us to know how satisfied are you, okay, based on this. For example, now I treat all of you go to KFC, okay? So I ask the first person, do you like this KFC? Okay, between 1 to 10. Okay, I give you the scale. Then he said 9. Then another person, the same thing, okay, he give 8. Then I know that this person is more, wrong signal. It's more happy than this person on this KFC trade, right? So it's the same thing. When we comparing the utility, okay, we just want to measure, okay, the level of satisfaction. By right, the value itself, this value has no meaning. No meaning meaning that people cannot say, oh, 9 and 8. Actually, okay, this is a bad example. It's a bad example, I must mention here, because in economics, we normally don't compare between people, right? We only compare among the people. For example, I give you KFC and I give you McDonald's. Then I ask you, this one you give how many marks? You give 9. This one you give 8. Then I know that you actually prefer KFC more than McDonald's. Okay. In the economics, we don't compare between people. We only compare between the goods, right? Okay. Yeah, so just how the bad example, can you please forget it? Okay, yeah. So for this level, therefore the value itself, okay, has no meaning. It's just a scale, okay. It's just something, you know, just a numeric values, okay. Yeah, because some people, their scale maybe is a 1 to 100. So when they say, oh, I love a KFC, I give a 50. You may think that, wow, 50 is higher than 9. Wow, you love KFC very much. No such thing, okay? It's based on the scale it has, okay? Let's say this one, actually, you don't really like, only give a 50 marks, okay? But this one give almost up to 100 already, 10 marks, okay? Yeah. So utility function does help us to value the level of satisfaction or the level of happiness for one person, okay? When we come to finance, okay, it is the level of satisfaction or preference for the investor. In microeconomics, it's a consumer, or right, okay, but here is the investor. So the role of utility in investment decision, okay, again, different investor have a different utility function. As I said just now, okay, my bad example. Normally, we don't compare between the utility function, okay. For one investor, you can compare between their investment, but you cannot compare investor A and investor B, okay. And this kind of a different utility function will reflect attitudes toward risk. Why we want to have a utility function? Because we want to see this investor, what is his attitude towards the risk? What is his preference for certainty or versus uncertainty? What is his investment goal and horizon? Okay, because each investor value the outcome differently. So the same investment can be very attractive to one investor, can be very unattractive to another. Okay, so this is a central idea. One day, okay, when you start working, maybe you will join the finance sector, okay, yeah, or any other sector, okay, which deal with a finance thing, okay, yeah, you will always need to remember this. You cannot sell the same policy to whole world, the whole markets, okay, because a different investor, usually they has a different preference, okay. Come to me, the simple example, okay, for the insurance. Okay, nowadays the insurance company, they also have this kind of apps one, you know, the app. They can test your risk, okay, test your attitude toward the risk preference this kind of thing. Okay, so for example, my agent, okay, nowadays before they sell me the new policy, they will ask me first, okay, they will set some question to test me, to test my attitude toward the risk. Okay, so last time my agent, okay, 5 years ago, when I told you, all right, I bought my first insurance after I start working, okay, yeah, I didn't buy it when I was a student, okay, so I start my first job at 31 years old, okay, after I complete my PhD was 27 to 30 years old, okay, so I start my first job at 31. Okay, so after I worked for a few years, because my agent, they definitely wanted me to buy more policy, right? More insurance. Okay, but then sometimes the policy that they sell me, I might not, you know, like here mentioned, for me may be very unattractive. So therefore, nowadays, even insurance company, they are very smart. They ask us to do the test first, okay? Of course, again, humans are not patient, right? Okay, same goes to me. So the question actually very simple one, maybe only like 5 questions, okay, or 10 questions. They just want to see what is my attitude toward the risk. What is my preference, okay? And this really helps, you know, because after that, okay, they say that, oh, okay, actually you are quite a risk-averse person. So they sell to me something that, you know, can protect my risk, okay? For example, how to do it? Maybe after 30 years, okay, I can take back my money. But meanwhile, because of when you can take your money back, right? Normally this premium itself, they won't have a too attractive thing. Maybe they only pay me lesser than the other plan, right? But for me, okay, that was the first time I think that, oh wow, okay, yeah, you see in the real world, in the industry, okay, they also understand this kind of thing. Okay, they understand that different investor, they actually have a different utility function. So they make it into practical way. They test you before they sell their thing. Okay, they sell their product. For me, I think it's a very brilliant, very smart, okay, because if I already know different investor value outcome differently, okay, so I not necessarily have to sell you the same policy. Okay, I should sell something that you can accept, okay, which you are more happy with it, right? So for me, this definitely can apply in many, many places, okay? One day when you start working, okay, maybe you join a company, okay, you need to sell your product, you can always think back about this kind of idea, okay? Because investor always value the outcome differently. Same go to consumer. Consumer always have the different preference, okay? Yeah, so yeah, this is a key. So, and also utility and the rational decision making. Okay, in the expected utility theory, a rational investor evaluates uncertain investment by their expected utility, not just expected return. Do you all still remember this? Okay, we learned about this, right? Expected utility. Okay, why we are not evaluate it by using the expected return? Okay, in the microeconomics, this has been covered, right? Okay, we say that, okay, yeah, in the utility theory, they figure out that sometimes people, when they lose the thing, they feel more sad, okay, than when they get the thing. Okay, for example, what does it mean? Okay, for example, let's say now your salary is 1,000 ringgit. This is your salary, Now, let's say I'm a boss. I say, okay, guys, you perform very well, okay? This year, I want to increase your salary to 1,100. Okay, for some people, they will feel, oh, wow, so happy, okay? At least I have a 100 increment, okay? But if I say, okay, this year, I don't perform well, okay, the company, I want to reduce your salary, okay, for 100 ringgit. So you will have a 900 per month. Believe it or not, okay, this one, not many people will be too happy about it. The worker maybe think in their heart, aduh, boss, so good, okay, I think our company performs so well. You only increase me for 100 ringgit. Are you sure? Are you kidding me? I should find a new job already, okay? This is a stupid boss. You may have this feeling, even though you have a 100 extra. But if the boss decided to to reduce your salary, okay, to 900, I think I can tell you, okay, let's say, just give an example, this one, maybe 10% people will feel like I want to find a new job already, okay, you only increase a 100 for me. But if I reduce, this one will be up to 90% of people, maybe they want to find a new job, okay? So the utility theory already tells us, sometimes you lose something, you feel more sad than when you gain something. I think this is very true, isn't it? When let's say if you pick up 5 ringgits from the somewhere, okay, then you may feel happy, but this happiness may be only 1 hour, okay, or 1 day. But if you lose this 5 ringgits, you may feel sad for 2 days. You say, where did I drop it? But of course, a 5 ringgit is just a small amount. I give you an example only. If you think in the real life, a lot of people, majority, have this feeling. When we lose something, we feel hurt more than when we gain something. It is true. So utility theory is a very powerful theory. They already can predict that people, okay, they usually, okay, yeah, we have to evaluate the uncertain by using the expected utility, but not the expected return. Okay, because this one is the expected return. You increase up to 1,100. But your happiness is not measured by this return. It's a measure by the utility. Okay, so therefore, okay, yeah, a rational investor, they always choose an investment that maximize the expected utility, not maximize the expected return. Only they maximize the expected utility. Therefore, this is the reason why in the microeconomics we learn about insurance. Right? I think you all learn about this, right? Don't tell me you haven't learned, If you already learned this, I think easier for you to understand this chapter. Okay. Yeah. In micro, especially micro 3, I think a lot of you should have learned this, or micro 2 when consumer theory. Okay. Yeah. So the most important is we want to maximize our expected utility lah. We are not expected return. Okay. Not measuring this expected return, but expected utility. Okay, yeah. So formally, we always want to choose an investment that maximize this. Okay, utility. Okay, not only this, but this. All right. Okay, but anyhow, this is a powerful word. Okay, this theory, the utility theory, is only applied when you are rational. Okay, because after that, behavioral economists already figure out, right, a lot of people are not rational. Okay, yeah, even those you know, they are this kind of thing. Okay, consumers sometimes, even investors, sometimes they are not rational. Rational one, maybe they did lots of homework. They really think about it, about the the return and the risk. They consider everything. But irrational one is just maybe, oh, your friend invests. Oh, I also follow you. I just invest without doing any homework, right? Just throw all your money in it. That is called irrational lah. But now we are talking about irrational people only. Okay, yeah. So yeah, so this is a thing. So the risk preference and utility shape, okay, you have to understand the risk and the utility, they are abang ade, okay, they are kawan, okay. So whenever they consider risk, they have to look at the utility shape as well. If you're a risk adverse investor, usually you have a concave utility function. If you're risk neutral, then you are linear. Risk neutral means that it's okay for you. Okay, so you are linear. But if you are risk seeking, normally you are convex. Okay, so the shape determines how much risk an investor is willing to accept it. Okay, so now suppose, okay, there are n outcome. You see, you have an n outcome. So the investor, okay, again, because utility only can be ranked. Okay, you cannot give a one value 9. 9 means what? Okay, normally you compare with others, compare with 8, compare with 10, then you know that, okay, sorry, I always put the wrong side. Okay, so 9 is bigger than 8, then you know that you love KFC more than McDonald's, for example. Okay, so let's say pizza, so you love a pizza the most, at least you have to rank. So there are n outcome, so you can rank the outcome in order for your of the desirability. So from the least to the most, okay, we can rank it. So question is, how is utility assigned to an outcome? Okay, so for example, this utility, okay, we assign it as a value C1. Okay, for example, just give an 8, 9, or 10. Okay, so utility is not unique. Okay, again, we must emphasize to you this, utility is not unique. Not unique means that you can always change one. For example, you can use a 1 to 10 as a scale, or you can also use 1 to 100 as a scale. Okay, so they are not unique. They are just ordering is matter only. Okay, you can give any numbers. If you love, you can give 1,000 also, never mind. So you are always free to normalize the utility. Okay, so if let's say you already compare between 1 to 10, then this value should be 1 to 10. But if you're comparing between the 1 to 100, then this should be 1 to 100. Okay, if you 1 to 1,000, then 1 to 1,000 lah. Okay, it's up to you. But important is the order. All right. So for I between 1 to n, the investor is given a choice. Let's say now I give you 2 choices. Okay. Option A, you definitely will receive this amount of money. Okay. For example, between 1 to 10, you definitely will receive 5 ringgit. But option B is a lottery style. Okay. So you have a probability that you will receive C1. C1 is the worst outcome. Let's say C1 is equal to 0. Okay, receive no money. Then CN, okay, the best outcome. For example, CN is equal to 10 ringgit. You will receive the highest amount. Okay, while CI is somewhere between, okay, like maybe 1 ringgit, 2 ringgit, 3 ringgit until 9 ringgit, okay, depending on how much risk the investor is willing to take. Okay, so now this investor, they compare certainty with risk. Okay, now they are comparing. This is a certainty. Okay, certainty. This is a risk. Okay, so what are the expected value? For the first experiment, okay, because you certainly receive this money, right? So your expected value is equal to that value, okay? But for the second one, because you are comparing between the option, right? So the first one, let's say this one is a 0.5, then 0.5 multiplied with the value, okay, the value, then you plus with another 0.5 multiplied with another value. Okay, so this is how we calculate the expected value between the two experiments. Okay, so how about the utility? Okay, when come to utility, it's the same. Okay, yeah. Actually, this one should be expected utility, I think. Yeah, because or expected value only. Because this one is a utility function. Okay, in this case, we use a probability for sure you will receive this, plus with a probability that you for sure you will receive this. Okay, then you can see you can plot this utility function. Okay, so for the investor, they are indifferent to the choice. Okay, between C1 and Cn, they are indifferent. Indifferent means that their utility is still the same lah. Not their happiness among these are always the same. Okay, so this is a thing. Okay, we want to make sure the investor have this indifferent feeling. Okay, so now how to apply it to the utility function? First, okay, the investor has two investment schemes. Like just now, the certain one, for sure, they will receive this money. And the second one is the uncertain one. It's a more to lottery, okay? It has a highest risk one, okay? So let the set of all possible outcome be, okay, from C1 until Cn. Each outcome Ci has a probability of occurring until this, okay? For the first scheme, you have a PI. For the second scheme, you have QI. This is just a probability, okay? The probability of occurring. So the utility of an outcome is equal to this, okay? Okay. So this one, then this one is should be expected lah, okay? Because this one, if let's say it's not utility, they are only expected return, okay? So now, okay, if we are now only expected utility because this one is a utility function. Just now was just as return. So I think this one is to be expected. Okay, yeah. The difference in the microeconomics expected return, okay, it's just a probability, okay, multiplied with the return, right? Okay, but then if a utility, expected utility, this is what we learn in the micro. So I think this one should be expected. Okay, so in this case, you can see the expected utility is simply the probability weighted sum of the utility. Okay, so for the you use a probability, okay, multiplied with a utility of the return. Okay, then while for or you can write in a simple way lah, in this way. While for the second scheme, okay, this type is a Q because here they say my first one is a P, the probability is equal to P, while the second one, the probability is equal to Q. So therefore now you multiply Q with a UCI. Okay. So for the decision rules, okay, if you are rational, okay, yeah, if you are rational, then you always choose a scheme with a higher expected utility, definitely, right? So if let's say the PI multiplied with the utility of CI is greater than the QI multiplied with a UCI, then this is a first scheme, this is a second, right? Okay, so by right, if a first give you a better expected utility, then you definitely choose the first scheme, right? So a rational investor prefer one investment to another if it yields a higher expected utility. You choose X over Y if the X give you the higher expected utility than Y. Okay, yeah, so this is the expected utility maximization principle. Okay. So for the concave, okay, concave function, we say that function is concave, okay, for all these value, okay, if the function value of the function at the average of 2 points is at least as larger as the average of the function value, okay. So here, again, all right, we just already learned if a concave utility means that they are risk adverse. Linear means that risk neutral. Convex means that risk loving. Okay, yeah. So why we suddenly introduce this concave? Okay, because based on this expected utility, a lot of people actually are risk adverse. Okay, yeah, majority are risk adverse people. Okay, so when we come to here, this is why, okay, the equation show you that, okay, the value of the function at the average of 2 points, okay, is at least, okay, this one is the average of the 2 points, is at least as large as the average of the function value itself. Okay, so therefore this explains to us that why, okay, majority people, they are risk adverse, okay, because we always want to choose, okay, based on here, we always want to choose the scheme with the higher expected utility. We are not choosing scheme with higher expected return. We are based on the expected utility. Okay, so the function also show you that why people will be risk adverse and they are concave, because we always choose the scheme give us a higher expected utility, not the higher expected return. Okay, so for example, now this investor, they must choose between the two investments, A and B. Okay, A is a lottery lah. Okay, you don't know one. If you have a head, okay, then you will receive 10 ringgit. If you have another, okay, otherwise you will receive nothing. Okay, but for B investment, you will receive M with certainty. This is also same like our microeconomics, right? So we say that this investor is risk adverse, okay? Okay, with the utility function. Okay, let's say they say this investor is risk adverse with a utility function. So now we have this utility function. We want to calculate the expected utility. So how to do it? For the first one, if I go to heads, we have a 0.5 probability, right? Otherwise, another one is also 0.5. So you can see this is a probability, okay, 0.5 multiplied with U10, the utility that you will receive 10 ringgit, plus with 1/2 utility of you will receive nothing. Okay, how to calculate this? Okay, let's say 10 here, U10 will be equal to 10 minus 10 squared divided by 25. So 10 minus 100 divided by 25. So it's equal to 4, right? So 10 minus 4. So it's equal to 6. So therefore, you have a 1/6. This one is a 0. So you will have a 0 value. So you only have this. So the expected utility for investment A is equal to 3. While for the B, you will receive an amount M with certainty. Let's say we don't know the value of M, but it's okay. We can just substitute inside the this utility function, and then you get expected utility for this case. So now the question is, okay, the question is, so should we choose A or should we choose B? Okay, so the concept is you will only choose A, okay, if the return for A is greater than the return from B, the expected utility. Sorry, I cannot say return. Okay, so this is a 3. This one is the expected utility for option B. So now you solve it, solve the equation. So you will have a M smaller than 3.49 or M greater than 21.51. Okay, so investment A is preferable to B when this value, okay, when you have a M smaller than 3.49, actually you prefer investment A. All right, okay, yeah. But if the value is greater than 21.51, then you will choose the investment B. Okay, because a smaller than 3.49, it can be 2.49. It can, of course, you may say, then how about if a 3.4? Okay, 3.4 not worth it, okay, because the value is quite near to 3, and then so but you have to bear the risk, right? The risk is quite high, either 0 or 10. Okay, so for them, if a less than 3.49, then you better you take the investment A. But if the return is so high, 21.51 and above, then you better choose investment B. Okay, yeah. So overall, okay, what we have learned, okay, about this diversification can be applied to the famous CAPM, the capital asset pricing model. Okay, this CAPM is a famous model in the finance. Okay, even until now, I see many PhD students, they always apply this. So they want to study how risky an individual security is when it is held together with the entire market. Okay, they are comparing individual security, okay, individual security versus the entire market, okay, yeah. So they are assuming that, let's say I'm invest in bond with the whole finance market in Malaysia, okay, financial market. So instead of looking at the asset in isolation, it asks how the asset behave relative to the market movement. Okay, so therefore the capital asset pricing model is important because it helps the investor to see how this individual security can move, okay, relative to the whole markets. Okay, so suppose now you are assuming, this one is a individual, this one is another asset. So you have two. Security I, you have a return I. Market portfolio, you have a RM. Okay, the weights, okay, let's say you invest X in this security I, so the rest you invest in the market. Okay, so the portfolio return will be like this. Okay, this is a probability, okay, the fraction, okay, that the fraction that you invest, this is another fraction that you invest in the market. So now, if you want to calculate the expected return, then just calculate it, okay, the portion that you invest in the RI and the portion that you invest in the whole market, okay, then the variance will be equal to this, all right, okay, then the expected value, this is a formula, expected value and the expected variance, okay, yeah, can be rewrite it like this. So all this information are given. Okay, so these are the formula. So the formula for this CAPM is you are comparing the return for the individual, okay, comparing with the whole market. Okay, normally CAPM, this one, the individual, they use the risk-free rate, okay, because they are comparing, okay, for how to say, they are telling us how much worth it for you to take this asset comparing to those risk-free one. Okay, or another way is this is better. Measure the extra return for taking the risk, okay, because the CMPM help us to calculate what is the returns if when we willing to take the risk. Okay, this extra return we always call as a risk premium. So CAPM, they are compare a risky asset to the guarantee one. Okay, let's say this one is a guarantee one because they are risk-free. Okay, and you are comparing it to the risky asset. Okay, so this is a return from the market but minus out this risk-free one. Okay, so the beta I, okay, the actually, okay, the correlation, right? Some like this, they are the sensitivity of XI to the market movement. So therefore, you can see this beta is actually using the same like the correlation formula. Okay, the covariance divided by the variance of it. Okay, yeah. So it will help you to measure the risk. Okay, the extra risk for you when you want to take this risky investment. So for example, okay, now you have a risk-free interest rate is a 5% per year. Okay, you already know, for example, in Malaysia, you already know that you can invest in a fixed deposit. Maybe the interest is only 3.5, okay, if a promotion rates lah. Nowadays, I think around 2.8, something like this, okay, yeah. So instead of invest your money in this, okay, let's say the return on the market is a 9% per year, but the volatility is equally high, it's a 35% per year. So you can see, okay, yeah. So now they further suppose that the covariance they already give you is a 0.1. So they want you to estimate the return on the stock, okay. So using the CAPM, the beta, okay, because why we want this? Because later we want to get this value. After that, we want to substitute back to here, right? Okay, so that we can calculate the expected return. So here the covariance, they already give you 0.1, so you just substitute 0.1. Okay, and this one is a variance, right? The volatility. So therefore it's a 35. So you put 0.35 because this is a percentage. Then you square it. Okay, this is a formula. Okay, from here. Then you get 0.8153. Okay, then after that, you can substitute it. Let's say here you already know it's equal to 0.5. So you put 0.05. Okay, beta is equal to 0.8153, 0.8153. Then this one, the RM is 9%. Okay, the return of the market is 9%. So it's a 0.09 minus the 0.05. Then you just calculate it. So you get this value. Okay, so this tells us that, okay, the risk, okay, is around the return, okay, the return for this stock is around 8.27%. So it's up to you whether it's worth it for you or not, because the risk-free is a 5%, okay, but the high risk one is a 8.27, something like this. Also, the CAPM help you to decide, okay, whether you want to invest in this stock or not. Oh, last slide. Okay, any questions that you all would like to ask? Now what time already? Oh, now it's at 2 o'clock. So you already can try the quiz. Okay. So if you all have no questions, make sure you try the quiz, okay? Because this one I will record it as your attendance. Okay, those who did not try, then I will assume that they are absent. Okay. So please try the quiz. So if no questions, that will stop here. Okay, next week I will see you in the class. Okay, yeah, so is it okay? Already 2 at 10. So please try. Okay, it's a very simple question, but it's all about today lecture. Okay, any question before I end the class? Okay, so if no questions, I will see you next week. Okay, thank you, class. Yeah, I remember. I wish all of you a happy new year. Okay, yeah, so we all have to welcome the new year with a happy and a healthy body, right? Yeah, okay. So happy new year. See you next week. Don't forget to submit your homeworks. Okay, especially assignment, especially tomorrow is a New Year Eve. I don't want all of you go for holiday until you forget to submit your homeworks. Okay. Yeah. Please submit, yeah. Okay. So I will stop here. See you next week. Try the quiz. Bye-bye, everyone.
Thank you,
Thank you
Doctor.
so much, Doctor.
Thank you,
Have a good
Doctor.
day.
Bye-bye.
Thank you, Doctor.
Bye-bye.
Thank you, Doctor.